Introduction. The DF-5B, Dongfeng 5B, NATO reporting name CSS-4 Mod 3, is a silo-based, two-stage, liquid propellant intercontinental ballistic missile ICBM that China fields as a heavy-throw, strategic deterrent. An upgraded successor to the Cold War-era DF-5, the DF-5B is most notable for its conversion to multiple independently targetable re-entry vehicle MIRV capability and its ability to place multiple nuclear warheads on separate trajectories from a single launcher. The missile's range, payload capacity, and reported accuracy make it a central element of China's long-range nuclear forces and of contemporary analyses of Beijing's strategic modernization, design and physical characteristics. The DF-5 family is a very large, two-stage ICBM. Publicly available technical descriptions list a length of about 32.6 meters, a diameter of roughly 3.35 meters, and a launch weight on the order of 180 to 183 tons. The missile uses storable liquid propellants, commonly reported as UDMH fuel and an NTO-type oxidizer, and is launched from hardened silos. The two-stage liquid design yields a high throw weight. Historical estimates for the DF-5 baseline gave a payload capacity in the multiple-ton range, several thousand kilograms, large enough to carry heavy single warheads or multiple re-entry vehicles and associated penetration aids range and performance. Open-source reporting and official Chinese disclosures indicate an effective range on the order of 12,000 kilometers or more, sufficient to reach most of Europe and the continental United States when launched from inland Chinese silos. Reported re-entry speeds place the vehicle in the hypersonic regime during descent, as is typical for ICBM re-entry bodies. Published accuracy estimates vary. Recent reporting cites a circular error probable, CEP, in the several hundred-meter range. Commonly quoted figures are roughly 500 to 800 meters, which, combined with large yields, supports strategic counter-value and counterforce missions depending on warhead choice, warhead configuration and MIRV capability. The defining characteristic of the DF-5B relative to earlier DF-5 variants is its MIRV adaptation. The missile is modified to carry multiple independently targetable re-entry vehicles rather than a single large warhead. Open-source estimates of how many warheads a DF-5B can carry differ across analysts and institutions. Some authoritative compilations, for example SIPRI and other defense analysis bodies, estimate the DF-5B's MIRV load at roughly up to 4 to 5 warheads per missile in conservative modeling, while other press and technical reports have cited broader ranges in public discussion, reflecting different assumptions about re-entry vehicle mass, decoy, penetration aids, and trade-offs between the number of RVs and individual yield. Separately, Chinese state reporting and some media accounts have referenced very large single warhead yields, e.g., 3 to 4 megatons for legacy DF-5 variants. When MIRV, individual warhead yields are generally expected to be lower to accommodate multiple RVs within throw weight limits. Because outside observers must infer exact loadouts from limited public data, best practice is to treat specific warhead counts and yield figures as estimates with some margin of uncertainty. Guidance, countermeasures, and penetration aids. The DF-5 series employs inertial guidance with onboard computation and, by modern upgrades, likely some form of improved navigation augmentation. Analysts report the use or potential use of penetration aids such as decoys and chaff, and modern MIRV buses that separate and guide multiple RVs. These measures are intended to complicate missile defense interception by increasing the number of re-entry objects and reducing the probability that defenses can reliably discriminate real warheads from decoys. The DF-5B's large throw weight makes it a convenient platform for carrying a combination of warheads and penetration aids, operational posture and basing. Historically, the DF-5 family has been a silo-based system. Earlier deployment patterns included storage in horizontal tunnels or silos from which missiles were moved to the launch point and fueled prior to firing. Fueling of large liquid propellant missiles imposes a slower launch cycle and a different survivability profile compared with road-mobile solid propellant systems. The DF-5B appears to have been introduced as part of a broader modernization that diversifies China's deterrent mix, adding MIRV silo-based heavy ICBMs alongside newer road-mobile solid propellant missiles. Open-source tallies over recent years have estimated several dozen DF-5 variants in China's inventory, with a subset modernized to MIRV capability. Exact numbers of deployed DF-5B silos are not publicly confirmed and are routinely updated by defense analysts. Strategic implications. Converting a heavy silo-based ICBM to carry multiple warheads substantially increases the number of targets a single missile can hold at risk, complicating an adversary's calculations about the size and disposition of strike packages needed to negate an opponent's deterrent. MIRVing increases the force multiplier effect of a limited number of launchers and can be seen as a hedge against ballistic missile defense developments by making effective interception more difficult or costly. At the same time, MIRV deployment can have stabilizing or destabilizing effects depending on doctrine, command and control safeguards, and the broader force structure. MIRV arsenals can incentivize arms race dynamics if adversaries respond by adding more launchers or developing countermeasures. Analysts emphasize the role of transparency, arms control measures, and crisis management channels in reducing miscalculation risks associated with rapid changes to nuclear force structure. Known public disclosures and reporting. In recent years, China has been less secretive about certain technical attributes of older strategic systems, and state media and official channels have on occasion published details about the DF-5 family that analysts have then assessed and debated. Open-source outlets and think tanks have used imagery, parade displays, and government-sourced descriptions to refine public estimates of range, size, payload, and accuracy. Because national reporting, commercial media, and independent research institutes use differing methodologies and access to information, readers should treat precise numeric claims, for example, exact warhead counts or specific yield figures, as subject to revision as new evidence emerges. Limitations of open-source estimates. Two categories of uncertainty affect public understanding of the DF-5B. First, internal Chinese program decisions, warhead miniaturization levels, numbers of RVs chosen per missile, and operational loadouts, are state secrets for obvious national security reasons. Second, open-source analysts must infer capability from limited imagery, parade displays, state media language, and occasional official disclosures. Different assumptions about RV mass, penetration aid mass, and guidance package weight produce different capacity estimates. As a result, reputable sources often present ranges for warhead counts or yield rather than single definitive values. Where possible, cross-referencing multiple independent analytical sources, technical publications, arms control databases, defense think tanks yields the most balanced view. Conclusion. The DF-5B represents a strategic modernization of a long-standing Chinese ICBM line by adapting a heavy, high-throw-weight platform to MIRV capability. With an intercontinental range on the order of 12,000 kilometers, silo basing, storable liquid propellant stages, and the capacity to carry multiple re-entry vehicles and penetration aids, the DF-5B enlarges the targeting options and survivability calculus of China's strategic force. Open-source estimates vary on the precise number of warheads carried per missile. Institutional estimates commonly cluster around a few warheads per missile, with conservative technical assessments often citing up to about 5 RVs in modeling, and reporting on yields and accuracy differs by source. These differences reflect both technical trade-offs in MIRV design and the information limits imposed by national secrecy. For analysts and policymakers, the DF-5B underscores the continuing importance of careful monitoring, rigorous technical assessment, and diplomatic channels to manage the risks that follow changes in strategic force structure.